Okay, it's the top of the hour, so I believe we're going to get started with today's webinar on productivity in the concrete industry. Why is it stagnated and how can ACI help? We have a few slides to go through here. During the webinar, you'll be able to enter
Hey,
questions.
Mike, you need to hit the record button.
I did.
Okay.
So during the webinar, go ahead and use the Q&A box for questions. There'll be 3 codes given out during the session, one at the beginning here and in just a second, one in the middle and one near the end. Record those and then you can get your PDHs using under My ACI on the ACI website. This session's been approved for 2 hours of continuing education through AIA. And the learning objectives, I believe, were in the session app. You can look at those. They're repeated here. And the first code for this session is YUL4. I'll give people just a second to make sure they've got that copied down. Okay, and now I'm going to turn it over to our moderator. Kerry Kaczynski is the currently a vice president unless they're playing a huge mean April Fool's joke on him, he's going to be president on Thursday, April 1st. So you can go ahead and introduce our first speaker. Well, I guess you'll be our first speaker, Kerry. And you're still muted.
There we go. Thank you, Mike. Well, I hope it's not an April Fool's joke, although it may be. We'll find that out in 2 days. As Mike said, I'm the current ACI Vice President, Senior Vice President, and I'd like to thank everybody for attending today, virtually, of course. We have 5 diverse speakers, and we intend to create a diverse perspective on construction productivity, why it has stagnated, and what we can all do to assist in moving that forward. So let me start my presentation. Oh. Mike?
I believe I'm seeing your email there. There we go.
All right. Minor hiccup there. So productivity in the concrete industry, why has it stagnated and how can ACI help? As I said, we're going to hit this from 5 different vantage points, and I'm a structural engineer, a designer, so I'll be speaking from my perspective in the world of structural design and how we coordinate with contractors and all the other players in the value chain of creating buildings. Let me begin by talking about a report that was issued 4 years ago now, 2017, by the McKinsey Global Institute. Now, a number of organizations have studied this topic over quite a number of years, the topic of construction productivity and why has it stagnated and what can we do to change that. McKinsey is one of the more recent, probably the most recent in terms of their global perspective. And what McKinsey did is a deep dive into construction data from 41 different countries. They compiled the data, issued a report on their findings, and it was pretty sobering. Here's one statement from the report that more or less sums up their conclusions. And what they concluded was that we're not going fast, we're not going forward very fast in the world of construction and construction productivity. In fact, the term they use is that we're stuck in a time warp. And what they essentially said is whereas most other industries, both in the US and globally, have been making advancements in terms of human productivity, that for various reasons in construction, we're not. And essentially, we've gone almost nowhere since right after World War II. Now, there are bright spots, and there are certainly areas in construction that are moving forward much faster than others. Modular construction, for example, prefabrication of building components. I think a lot of advancements have been made. So it's not all gloom and doom. But if you aggregate the data and compile the data into some conclusions, the conclusions are not very good. Here's a chart that sums it all up. So what you can see is construction productivity at the bottom in the reddish orange color, overall productivity, and this is in the US. This is in the US. Overall productivity is directly above construction, and then so on it goes, manufacturing, wholesale, and retail, and agriculture. So if you look at overall improvements in productivity since 1947, so this goes back over 70 years, they've been pretty good. Human productivity has increased about threefold. And what's interesting is that in construction, we were tracking that trend line until about the mid 1970s, early 1980s, and then we went on a slow downward trajectory, which seems to coincide with the technology revolution, which may indicate that our gears are grinding a bit in the way we use technology. We're not integrating our technology as efficiently as we could in the world of construction. That might be one of the conclusions. I'll talk more about this here in a minute. So what did they come up with in terms of how we can improve this? Construction productivity has been stagnant for decades. And the question is, what do we do to change that? McKinsey came up with 7 primary recommendations, and I'm going to go through 3 of them that I think are the most important. One is reshape regulation. And what they said is that we've created permitting and approval processes that get in our way. I think sometimes in our industry, our default response to new challenges is to write more rules and embellish the codes and see if we can set up a new committee to write another code or whatever the case may be. And that isn't necessarily a bad thing, because as the knowledge base expands and as the technology that we're using grows with it, it's incumbent upon people in the world of code writing to follow that trend. So of necessity, our codes become bigger and more complicated. But we may sometimes carry that a little too far. And that was one of the points McKinsey made, is that we're building some pretty high walls to climb in terms of permitting and approval. Another was that we should move from prescriptive to performance-based codes and standards. This, I think, is a real bright spot in our industry, because there has been a trend for quite a number of years now to allow performance-based approaches and to encourage their use. And I think a lot of progress is being made, for example, with respect to material supply. Quite a long time ago, the P2P initiative developed in the ready-mix industry, and it was designed to encourage specifiers to think performance, not prescriptive. So move from prescriptive to performance, let the people who design mixes all day long come up with the recipe for the mix, and the specifier would only prescribe the outcome or specify the outcome that is desired. And that's a real positive trend. Also in the world of design, the same kinds of things are happening. Rewire contracts. And what they said is we create a lot of contractual silos in the world of construction. This, I think, is a major issue. We're not going to solve that here today. In fact, it may not be something that ACI can really do much about, but it's important to be aware of it, because the world of construction is highly fractured. We have a lot of players involved in building a building, all the way from the material supply and the material fabrication, all the subcontractors, the general contractors. On the design side, we have many, many different firms working on the design of a major project. And we all tend to build a firewall around our piece of it, and we build a moat around our respective responsibilities. And we don't always keep our eye on the overall objective, which is to build a good project on time and on budget. So we need to lower the moat a bit, drop the silos that we tend to build around our supply chains. Move toward contractual alignment. That's the flip side of what I was just saying. If we can incentivize everybody on a team to think about a good project on time and on budget, and create the teamwork by doing that, we take a major step in the right direction. And incentivize all parties to target these desirable outcomes. Now, integrated project delivery, IPD, is a big step in the right direction in that regard. IPD developed quite a number of years ago. It's not used as often as it could be, but when it is used, and if it's used for the right project, and the right project being one where you need better coordination, you have a lot of players involved, And it's important that people are incentivized to think about the overall outcomes. Integrated project delivery can work very, very well. We'll actually have a presentation on that later today. Rethink design. Now here we need to start from the bottom up. And by that I mean we need to start with better constructability thinking introduced early into the design process. I'll talk quite a bit about this with some examples that I'll use, but constructability is crucial when you're designing a building if the goal is to create efficiency and cost control, which for most every project it is. Constructability thinking is very, very crucial, and it's important that it be introduced early. And then along with that, we can improve productivity through better coordination of the technology that we all use. Some of you on the call, perhaps most of you, can relate to the fact that when BIM was first introduced into our industry many years ago now, one of the real objectives with BIM was that it would allow us to share a model in real time. And by sharing a model in real time, we'll have the clash detection benefits and so forth that are associated with that. And in my world, that doesn't happen too often. I think too often we all build our own model, and that instead of working on the same live model, we all build our own. And then we hope at the end that they can talk to each other. Sometimes they can, sometimes they don't. So let's move on now and focus on constructability. And first of all, what it means and how we can introduce better constructability into our designs. First of all, the definition of what constructability is. It's the incorporation of construction thinking into design. What it isn't is the completion and coordination of design documents. That also is very important, but that is not constructability. Both topics are critical to moving the ball forward, but our focus today is constructability. Document completion and coordination is a separate topic, very important topic, and arguably the quality of construction documents has degraded a bit. I think a lot of the contractors listening could probably relate to that for various reasons, the completion level of documents and the overall level of quality might not be as good today as it was quite a long time ago. That is an important topic, but that's not the focus today. So let me go through some examples that illustrate the key points I want to make. I want to start with a project in Las Vegas. This was designed to be a 50-story tower, beautiful building right on the Las Vegas Strip. Here it is under construction. It's the building on the right side of your screen with partial glass on it. Got up about 25 stories, about halfway, and then construction was stopped for various reasons, primarily because it was determined that there were some defects in the structure, and that led to quite an extended period of litigation and the eventual elimination of that building. The building was completely demolished. And there were quite a number of reasons for that, and there was blame all the way around. It wasn't necessarily on the design side, the construction side, or ownership. There were a number of issues associated with the problems, but one of them was constructability. And let me show you an example here. We're looking at a beam schedule. These are shear wall link beams. So you see the schedule on the left side of your screen, and each one of those lines instructs the detailer how much top bar to put into the beam and bottom bar and stirrup size and spacing and so forth. You see the elevation up in the upper right, looks fairly simple. You see the section in the lower right. So the beam section shows a very simple beam, 2 top bars, 2 bottom bars, and a beam stirrup. If you take some of the data out of the schedule and plug it in and actually draw the beam, here's what you get. This was an image that was produced as part of the litigation process, actually, that the building went through, and my firm worked as one of the experts in that. And so we drew up images of these beams to see how they could be constructed. And in many cases, it was impossible. You could not build these beams the way they were drawn. Here what we have are 8 top bars, 8 bottom bars. These are all very large bars, upwards of 9s and 10s and 11s in some cases. The beam is 12 inches wide. You have 1.5 inches of clear cover to the beam stirrup. And then you have 4 stirrup legs. And you have to get all of that through the wall steel at the other end. So in many cases, the beams as designed and drawn were impossible to build. Unfortunately, the design and construction team had developed a lot of friction. There was a lot of ill will that had been created, and they weren't talking very well. And so working out these constructability problems became very, very difficult. And the consequence was that major flaws were built into the building and it was eventually destroyed. Moving to a different example. This is a building that my office designed in Seattle a few years back. It was a 32-story condominium tower downtown. Here you see it under construction, of course. And what I want to show you is the forming system that was used to build the decks. So here's the building going up, and you can see 2 levels of tables up at the top of the image. And those deck forms are suspended off the columns. It's a column hung forming system. And the beauty of that is that you eliminate all the shoring, you eliminate all of the reshoring. Since you're not putting any slab loads on the floor, there's no reason to reshore. And because of that, the following trades can be much closer to the structural deck. So you can have the following trades behind the structure working 2 or 3 levels below the deck that you're placing concrete on. Very unique in the world of big concrete buildings. The way that works, here's an image looking up at the bottom of the forming table, slab table. And you can see wood eye joists at the upper part of the image that sit on a stringer. There's a wide flange beam that is supported off of columns. So you'll see a bracket bolted through the columns. The wide flange beam sits on the bracket and the slab form sits on the wide flange beam. And you're literally looking up at the deck that they're placing rebar and concrete on. So you can be doing work following directly behind the structural crew that is associated with all of the plumbing, the HVAC, the cladding, and so forth that follow behind structure. Now, what I want to point out, let me go back to that just for a minute, is that the constructability message on this particular project is that we chose the forming system before we laid out the columns. We had a very cohesive team between the architect, my office as the structural engineer, the general contractor, the owner. We all knew each other. We had worked together on prior projects. And we basically sat out and talked about, how do we want to build this building? How can we speed it up? How can we improve the schedule and improve the budget? And we chose the forming system before we laid out the columns. So we actually were doing the constructability thinking right out of the gate when the building was still on tracing paper, instead of waiting until we're in construction documents. The forming system was one of the first decisions we made. And then the column placement needs to work with those tables. They need to be aligned in the transverse direction across the building. And that decision was made before we selected column locations. Here's another building using the same forming system, also in Seattle, that my office designed. The picture on the left, you can see the column hung flyers, if you look closely, supported off of the columns. And what's interesting in that picture on the left is the skin on the building is literally a floor and a half, 2 floors behind the structure. Now, you don't see that in a traditional construction system. If you use traditional fly forms or handset systems, you'll see the shoring and then 3 or 4 levels of reshoring. And you can't follow behind more closely than about 5 levels if you build that way. With column hung, you can be a couple of floors behind the structural deck. You can see the layout in the image on the right and how the columns are aligned in the transverse direction across the building, and the slab forms are suspended off the top of the column. My third example is a parking structure in South Carolina. This is the artist rendering. My office was contacted by Baker Concrete. I believe Mike Schneider is going to talk about this as well, but a project that Baker was involved in. They asked my office for some input and just to do some constructability reviews on various aspects of the design before they built it. The project was facing some schedule challenges and budget challenges. And so we did that, and we ended up working into a cooperative relationship with the structural engineer of record. And what we did was, and here's a picture of the building, of course, completed. This was about a year ago, finished up last year. maybe a little longer than that now, but that's the spiral. There were 2 spiral access points into the garage. And there it is under construction. And let me show you one of the examples of constructability that we brought to the table. First, before I do that, though, I want to talk about the system that was used to build it. When you build long span cast in place parking, most commonly you do that with what's called a Cunningham forming system. Now, and that's named after the gentleman who developed it many years ago, Art Cunningham. But the idea is that you set a beam form. This is a steel beam form. We're looking up at the soffit of this steel beam form. You set the beam form. The beam is bolted up in 10-foot segments, and then there's a makeup piece at each end, depending on the length of beam you're looking for. So if the beam is 62 feet, you'd have 6 10-foot segments and a 2-foot makeup piece. It's a steel beam form, sits on a scaffolding tower, and then all of the slab forms sit on a ledger that also is supported by that tower. The beam enters into a column. The column needs to be at least 2 inches wider on each side of the beam at the top of the beam. So if the beam at the top is 20 inches in width, you want the column to be at least 24. Unlike some systems where you want beams and columns to match, here we don't want that. We want the beam actually narrower than the column. So there's some nuances to the forming system that are very important to understand before you start doing the structural engineering. And there's the beam in cross section. You can see it has a 1-inch side taper so that you can strip it. The first thing when you strip the Cunningham system is drop the beam form. The slab forms on either side are supported at the slab soffit with coil loop inserts. Then you drop those down onto a forklift or a scissors lift, and off you go. You roll on to the next location. Now, I want to talk about something that would be seemingly insignificant insofar as it relates to structure, and that's drainage. Here's the plan of the project. This was a sizable project, about 1 million square feet. You can see the spiral ramps at the 2 corners. I'm going to show you the top half of this image, which is right here. And the diamonds that you see superimposed on that plan represent drainage. The horizontal lines at each diamond represent the high points in the drainage. The drains were located at the intersection of the beams and girders, and the horizontal line is the high point. To achieve 2% drainage slope, you had a couple of options. Either you increase the slab thickness by 8 inches to get from the beam to the high point. You increase by 8 inches, which means that your overall slab thickness would go from 7 to 15. And the engineer of record said, no, we're not going to allow that because that's too much dead load, and we haven't allowed for that in our design. The other option is you actually kink the beam form, so that instead of a straight steel beam form, you put a kink in the middle. That's very difficult to do with a Cunningham system. Can it be done? Yes, it can be. Is it a good solution? No. No, because it moves both schedule and budget in the wrong direction. Those beams become dedicated beam forms. They can be used only in that one location. So when you strip the formwork and want to move it off to the next pour, the beams that are kinked can be used only at the high point of the drain locations. So it can be built, but it's a very poor solution in terms of constructability. And the value that my firm brought to this project, and we had a very good and cooperative working relationship with the local structural engineer, was just to bring an understanding of this forming system and some of the nuances associated with it. There were also some seismic design issues that we added some value to, and the net effect was that we were able to improve the schedule by a considerable amount that I believe Mike Schneider will talk more about here shortly, and also the budget, just by bringing constructability thinking to the table. So the moral of the story is engage with the contractor early. Now, the challenge with that can be for traditional design, bid, build projects. If the contractor is not part of the team early, it can be very difficult to get the construction input necessary to create the constructability you're looking for. What I would say to that is it's incumbent upon designers, the way I view it, to build a network of construction people in their industry, ready-mix suppliers, subcontractors, fabricators, general contractors. If you have a network of people that you can talk with and get information with and share information with, even though you may not have a contractor for your particular project, you can still access information you need to create constructible solutions. The ideal situation is when you have the contractor on the team early enough that you can be speaking with the people who are going to build the project you're designing. Sometimes that happens. Obviously with design build, that's part of the motivation for design build. But for design bid build projects, that's not possible. And I would encourage people, the designers who are listening, build that network of contacts in the world of construction that will serve you well. And to sum it all up, the benefit of early constructability input, you see the green line, and on the horizontal axis, preliminary design, schematic design, design development, and so on, all the way through construction administration. The ability to impact cost is greatest at the early phases of design. You reach a point actually where the lines cross, and if you try to introduce significant changes to a design too late, you can actually have a negative impact on cost because you have too many dominoes on the table. And if you knock even one of those down, a lot of others are knocked over along with it. So the key to constructability thinking is do it early, do it in preliminary design, schematic design, and DD. And that way, by the time you reach construction documents and CA, you don't need to worry too much except to whittle around the edges and dot I's and cross T's. That's the conclusion of my presentation. Thank you for tuning in. And Mike Tholen, I will turn it back to you for questions if we have any.
And I think the only question that we had come in, I'm gonna, just 1 second, I'm gonna go ahead and show my screen again. I apologize to everyone. I didn't realize, I don't think I was actually sharing my screen when I was giving out the first session code. So I'll give that out again. It's YUL4 there. The only question we have was whether you wanted to give the name of the hotel that was the first one, the one that was torn down. I was kind of assuming you probably didn't want to identify the specific project.
Yeah, I'd rather not identify that. It was in Las Vegas. It was on the Las Vegas Strip. But I'd rather not identify it. If people would like to learn more about it, I think you can certainly find a lot of information on the internet.
Yep.
It was a major issue at the time, but and the case is completely settled, so there's nothing particularly confidential about it, but I think I'd rather leave that unstated.
Okay, then I think we can go ahead and move on to the next presenter.
Okay, our next speaker. This gentleman needs no introduction, but I'll give him one anyway. Mike Schneider. He's a senior vice president with Baker Concrete. He's been with Baker for 43 years. He's a past president of the American Society of Concrete Contractors. He held that position from 2005 to 2006, and they're better known as ASCC. He's a past chair of the Strategic Development Council of ACI. He's a past president of ACI in 2016 and current chair of the ACI Foundation. So with no further ado, I will welcome Mike Schneider.
Okay. Carrie, are you seeing the screen?
No, we're not seeing it yet, Mike.
You're not seeing it yet. Okay.
should be a green button near the
Yeah,
bottom.
I just did that.
And you click a screen, and then what I forgot to do was hit the share button down in the lower right after you picked which screen you want to show.
Okay.
There it went.
Okay, there we go. Okay, let's get started here. A lot of information to cover here, but I hope to talk about constructability and efficiency and how important that is to the overall industry. So as Kerry talked about just a few minutes ago about the McKinsey report, he went into a lot of detail, but bottom line is large projects take 20% longer to finish than scheduled and are up to 80% over budget. So a lot's been talked about with that. CII, which Baker is a member of, Brendan Bechtel was the guest speaker, featured speaker in 2016. And what he talked about was how much better manufacturing has done from a productivity standpoint. And he actually used the term, our house is on fire. We are an industry that's ripe for disruption. And all we got to do is take a look at the taxi business and what Uber and has been able to do to the taxi industry. So the construction industry is very ripe for the same type of thing, given some of the issues that we have allowed to develop. Question is, how's this possible? Look at the things that we've done better. We got mechanical drafting, we got CAD, GPS. We got a whole alphabet soup of organizations out there that are supposed to be helping with this. Well, here's my simple solution. I've never seen email drive a single nail or place a yard of concrete. And yet we think email is helping us be better builders. And so Chris Pruitt Webcor calls this the mobile modular office vortex. And I think we are all victim to this. If we take a look at what we used to do, we had master builders. We take a look at the Empire State Building, the Golden Gate Bridge, where again, the team was they financed it, designed it, and built it. And now what we've got is just a bunch of specialists that are out there working. If we look at the Empire State Building, it's still, at the time, it was the tallest building in the world. Now it's about 30th tallest, but literally the whole thing was built in just a little over a year, less than a year and a half. Finished 12 days early. And if you take a look at the people that built it, it was built primarily by European immigrants and Mohawk ironworkers, Mohawk Indians. Now let's contrast that with the Bank of America Tower that finished 10 blocks away. It's 1,200 foot tall, about the same. And it took 6 years, $2 billion in cost and 6 years to build. Just again, things have changed. As we take a look at manufacturing, how have they been able to get those numbers that Kerry showed? One, it's a mature industry. They got very refined processes, many multi-generational firms, and they've had the capital to put into the investment they needed to robotize and do some things from a manufacturing standpoint. In construction, it's a very fragmented industry. Every building we build is unique. We've got an aging workforce, and because of the competition, the returns just aren't there to invest in some of the necessary improvements. So I'd like to spend a little bit of time talking about a couple of possible solutions. Design details and timing. Terry alluded to some of this. Columns that are always changing sizes. Bottom of deck elevation changes. Lack of contractor input. That's how Kerry ended up. Redundant or inapplicable details. Lack of coordination. Those are all things that affect us out there on the job. Unfortunately, with computers, we've got endless permutations that are out there. In 1990, when we did a submittal, there was a vellum and 5 hard copies. And there were not a whole lot of changes because it was a lot of work to make a change. Today, nothing's like that. The designer sits in his office, makes a few changes, pushes send on his email, and the whole project team has got changes, and the pour that was ready when the crew left now has to be changed the next morning because it changes the guy just sent, the design firm. So some possible solutions: promote integrated project delivery. There's going to be some more on IPD, so I won't talk about this right now, but CII has done some studies, and it shows that basically a 2 to 5% reduction in project cost if we really pay attention to constructability. And there's some very good tools that have been developed by CII. We're all squeezed for more for fees. And sometimes the owner and designer and the contractor are not in alignment. We have conflicting interests. And again, a lot of times it's just a matter of covering the risk. And what we see today is certainly there's the risk get pushed downhill to the lowest people on the totem pole. Again, some of those solutions, team alignment from the entire team. Everybody on the job have common goals from the owner to the craft workers. And what we have to do is come up with better tools for the owners to make their decisions. Communications and planning, again, it's very fragmented. Every building's different. They're all one-off, so we have no advantage of the learning curve. CII has got a series of best practices that they put out there. And this last one, rely upon standard designs and construction methods whenever possible. There's just lots of things we can do to improve here. Right size, fast tracked. Time is the enemy. Everybody is in a time crunch. As the schedules get compressed, we have less time to plan. We actually end up with lower productivity. And part of what we've got to do is we have got to have better drawings before we get started. We were involved in a project. It was a parking garage. They wanted us to start with 60% drawings. And yet there was actually no demand for the parking because the building wasn't complete, but they had to get the garage going. And again, we see that more and more. And every time you start with those incomplete documents, it just causes a challenge to the project. We need to let the owners be aware of what that cost is of incomplete designs. And nobody's got extra money out there to put into a project. So let's do a better job and plan better. The labor shortage. We are not attracting young workers into this industry. Here's sort of the prototype of the construction superintendent out there yelling and screaming. And we have got to do something to attract young people. Mike Rowe, some of you have seen his PR campaign, but some of that is we have to highlight the use of technology and make it more attractive to younger workers. And a big issue is this work-life impact. The work hours, the conditions, those are all issues that we have. But certainly we have got to attract people into our industry to solve this workforce dilemma. Digital technology is moving too slow. Kerry alluded to the issues with multiple models. We've been on jobs where each subcontractor has to develop their own model. And again, the one that ultimately pays that price is the owner. So we have lots of knowledge. How do we optimize that knowledge that is out there? We need a new learning model. And basically, we are seeing this right now, but the use of more mobile apps on our iPads and our iPhones, and the use of virtual construction has helped tremendously. Productivity, we're not much better off than we were in 1964. One of the big factors there is overtime. And that's one of the solutions is to work more overtime, but we've all seen the charts that when we work overtime, it really doesn't, it actually makes us more efficient as people work consistent overtime. But there are rays of hope out there, lean construction, IPD, we have a presentation on that coming up. I think we're building better buildings, less leaks, and they're more durable. We've seen tremendous improvements in safety for our coworkers over the past several decades. We've got better documentation with as-builts, and we're starting to finally focus on workforce development again and leadership training. Carrie already showed this slide on IPD and the cost influence curve. And now what I'd like to spend a little bit of time on is talking about the forming economics. And some of this, Carrie had talked about the project there in South Carolina. But some of the things in forming, when does less cost more? And a number of people on the call here right now, I suspect, is who gets the A in the structures class or design class? It's probably the person that's got the least number of cubic yards or the least pounds of resteel. However, when we do that, when we look at permanent material reduction, we overlook the most important influence on concrete structural frame cost, and that's the formwork. And formwork, even though you don't see it when the project's finished, to put that formwork in there to support the concrete as it's put in place while it's still fluid is over 50% of the cost of a concrete frame. And so what we have to make sure of as we try to economize the project is we have to look at the entire process, just not the number of materials, but we also got to look at the time, the labor, and equipment that goes into it. It's the total cost that goes into it, just not the material cost. In order for that to happen, that has to start in the development stage. It's very important if the contractor can be involved early, if the designer is involved early and knows some things about formwork, we can start out with a design that is much more constructible and will have a reduction in cost. Again, there's no doubt that we are building buildings that from a life safety standpoint, they meet the 318 code. The project that Carrie was just talking about, there was absolutely nothing wrong with the original design from a safety standpoint, a design standpoint, but from constructability, a big difference. And after we got Carrie's firm involved, we were able to cut $2.5 million out of the project and at least a month out of the schedule. And same parking, again, same functionality, parks the same number of cars, and still very attractive, and the owner is very happy with what they got. So again, we have multiple solutions, but one may be much less expensive. And again, to do that, we have to have a sense of formwork logic, which we're going to talk about here. So basically, this all starts when you just start your freehand sketches. The designer can, if he's aware of these three things, can certainly affect the cost of the structure: design repetition, dimensional standards, and dimensional consistency. So when we talk about design repetition, the same layout from bay to bay of each floor. and then from floor to floor. And we can set it up like a production line. And again, we end up with, we optimize our labor productivity. We can use the same equipment, and we don't have to customize the formwork. You start with the same formwork and just move it from floor to floor as you are going. By the same token, if there's constant changes, then there's plan interpretations. You are readjusting your formwork, and it just costs a whole lot more money to do that from a constructability standpoint. Dimensional standards. There are some standard member sizes. If we look here at modules for concrete pans, if we use the standard sizes, contractors have those and they're able to amortize the cost of that over several projects. But we find designers, as we look at these numbers, you can see they're basically in 1 foot increments. But we'll see a job where somebody's got a 5 foot 3 inch pan. That's not standard. And what you end up have to do is the job is going to end up eating the total cost for those forms. And again, the real loser there is the owner, who ultimately is the one that has to pay that cost. So those dimensional standards are so important. Let's take advantage of what is out there. Again, we see that repeatedly with lumber. And again, a typical 2x4, most people know it's not 2x4. It's not a 2x4, it's 1.5 inches. And so if we just take a look at this here, if we start out here, if this is a nominal 6 inch dimension, that's 5.5 inches. And then you take your 3/4 sheet of plywood that you're going to be using, that ends up being 6.25 inches. So again, just a minute here. So that's one of the things that from a designer standpoint, if he calls for a true 6 inches, we're going to have to take plywood and cut it. And again, just in the design, put in there 6.25 inches and allow for what we're trying to do. So that again, we allow for that 3/4 sheet of plywood and then the use of the 2x6. And it's the little things like that the designer can do that greatly reduce the cost, both in terms of form material and in labor. So again, the dimensions of the structural member should reflect the dimensions of material used to form it. And there's an awful lot of designers that just haven't spent any time on the project to really understand what goes into it and how it's really being built. Dimensional consistency. Consistency and simplicity yield big savings. There's absolutely no question about that. And so this graph here, as it becomes more complex, the cost goes up. So some simple examples: if we maintain a constant depth of horizontal construction, if the soffit elevation on the bottom is constant, that is way easier to form than changes in the bottom, in the soffit elevation. And sometimes the designer thinks that he's helping things by saving concrete material, but he's better off paying for the extra inch of concrete and just having a constant dimension on the bottom. Column sizes as they change. We've seen projects where literally we had 30 different column sizes on a major hotel from floor to floor, or on one floor. It was absolutely absurd. The dimensional changes were in increments of, in some cases, it was a 1/2 inch. We tried to get that changed, and the architect said no, he needed the space in the room. It was a downtown project. There was no place to store all those columns. If we had standard column sizes, we could have had 10 columns on the job. and just moved them around on the floor. Instead, on this job, there were 30 different ones, and they had to go in a particular, there were columns on the floors that got used one time, that one position. And again, the cost to do that is just, it's unnecessary. The other thing is constant story heights. Keep the dimensions the same, and again, it's amazing what happens from a constructability standpoint when we are able to do that. So if we apply these three basic principles, we're not asking the designer to assume the role of a formwork planner. It doesn't make the structural design a slave to the formwork consideration. We're basically just be aware of what these formwork costs are, and let the designer take advantage of it as he is designing the building. And we can still come up with projects that aesthetically are pleasing. We can maintain the quality. The function doesn't have to change. But what really changes is we're able to impact the schedule. We're able to impact, we generally have less overtime, and certainly some cost implications. And certainly the attitude of the workers in the field, our coworkers, is dramatically improved. So as we go through here and we talk about, does this stuff really work? If we put all this stuff together, and I'm going to close talking about what the power of alignment can be. This is a picture from a petrochemical plant in Saudi Arabia. It's called Sadara. It's the world's largest petrochemical project ever built, and in a single phase. And when you see these numbers, they're just staggering. This is a joint venture of Aramco and Dow Chemical. And when this project started, Dow Chemical, the guy in charge of construction, the Dow Chemical board basically said, look, Dow Chemical's been a member of CII for since its inception. They have lots of good ideas on how to build things. We want this job to be built using CII best practices. And these numbers I'm going to tell you, I heard from the guy that was in charge of that job. He gave a presentation to CII, and he talked about how they did this. When you hear these numbers, you just shake your head, especially when you look at some of the things earlier about projects being over budget and over schedule. This job actually had 26 integrated manufacturing plants, each of them with their own design team, separate design teams. So 26 different plants that where there was interface. It was a $20 billion investment in Jebel City. The site in the laydown area, the site was basically 1.5 by 3 miles. And then there was another area that just duplicated that. That was a laydown. That was the laydown prefab area. So the job was 3 miles square. Huge project. 60,000 workers. Think about that. 60,000 people involved in this job, and can't even imagine how many different languages were spoken there. 425 million total man hours. From a safety standpoint, recordable rate was 0.033. CII contractors have an average of 0.3, and the industry average on recordable rate is 3.6. So again, if you compare that, this 0.03 to 3.6 is absolutely phenomenal, the safety record they had. The job was delivered on time. It was on budget. But the biggest thing that differentiated this job from lots of others is they incorporated the CII best practices throughout the entire project. And the Sadara way, which they preached throughout the entire project, was managing the soft stuff. It was constant communication. It was constantly letting people be aware of what the mission and the goal was. It was letting the craft workers, listening to the craft workers and their suggestions. It was incorporating lean principles. It was incorporating planning processes. And when that was all done, they ended up with a very successful project. And with that, that's the end of my presentation. Just so I say thank you. Mike, are there any questions?
I think we're going to have to go ahead and move on to the next presentation. I was going to share the second PDH code since we're near the top of the hour. So that's PZ3E that hopefully you are seeing on your screen right now. And I guess, Oscar, you can go ahead and start sharing your screen. And Carrie, if you want to go ahead and start introducing Oscar.
Sure. Well, first of all, Mike Schneider, thank you very much. Very interesting presentation. I want to learn more about that Sedera project. So next speaker, Oscar Tamate. He's the Chief Concrete Engineer and Materials Engineering Manager for Kiewit. He has 20 years of experience in the industry with a focus on concrete materials and construction. And he serves in a number of industry committees within ACI, ASTM, CSA rather, and TRB. He's an ACI fellow, and he serves in several different ACI committees, including as the chair of the Construction Liaison Committee. In 2019, Oscar was selected by Concrete Construction Magazine as one of the 10 most influential people in the concrete industry. Quite a distinction. So with no further ado, I'd like to welcome Oscar.
Very good, very good. Thank you, Kerry. Can you hear me and you can see my screen?
Yes, we can.
Perfect. Thank you very much for the opportunity to talk today. And my topic, I'm going to be talking about concrete constructability from a practitioner perspective. And in my presentation, the main goal is to first, provide an introduction a little bit to set up the stage, and then people can understand my point of view, the experience that we're going to discuss, a little bit of why this is important for productivity and constructability of concrete, and then go over a little bit of the project profile, talk about the design and construction aspects of the work, and then go over some of the lessons learned on productivity. So it's important that as you listen to my presentation, you get a little bit perspective of where I'm coming from, what I'm talking about, and what is my day-to-day, right? So when you look at the type of projects we typically work in Kiewit, you can see that it's pretty much heavy civil, large infrastructure, and sometimes large buildings, large bridges, dams, special applications, very, very innovative type of work for heavy civil infrastructure. So when you look at my opinions, when you look at my suggestions, when we look at why we do what we do, and the reasons behind the technical decisions that are done for design and construction, you can imagine that obviously it's a special, is necessarily, it's not necessarily comparable sometimes to smaller projects or even, buildings. So when we look at that, let's think about that, because obviously sometimes people ask me about, yeah, no, that makes sense for a large project, but obviously when you're talking about a small rural or city project, most likely that's not necessarily the case. But let's also focus about the opportunities that we can identify in these type of projects, so we can also improve constructability and productivity. And you can see there's a common theme from the presentations of Kerry and Mike and myself, that there's a lot of areas that are going to be very important in the way we implement productivity and constructability in design and construction. So something I've always been looking at in this topic when we talk about improving constructability to improve productivity is why. Why are we seeing this type of improvements in some projects, but we don't see necessarily the same improvements in other projects? And I can tell you from a quick, in a glance perspective, that I'm seeing a lot of these improvements in constructability and productivity happen in two main projects. First, accelerated schedule fast track projects that you actually have to pretty much crash the schedule and look at, deeply working with the design, with the client, with the different contractors and the local community to make sure that you're gonna be able to deliver on time. And not only that, but be able to go beyond the normal practices to do that. The other ones are emergency projects. In emergency projects on the right side, I'm showing here two projects most people in the United States are aware. These are the reconstruction of the pump systems and the levees in Louisiana when Katrina, we led that design and construction, and then we did the Oroville Dam repair after the big failure of the spillway. So you can think about why that means that you have improved constructability and improved productivity there. Well, as any human, when you're under pressure, right? When you're under pressure, you have to execute. When you're under pressure, you need to put all the pieces together, make sure they're going to happen perfectly. So I believe there's a very important aspect of why we see improvement in constructability and productivity when we do have the pressure to actually execute and deliver to the local community. And that's a very important aspect of what we're talking today. So let's talk about the project profile. The project profile we're talking today, it's a large a facility. It's a large facility in the west of the United States that Kiewit came in as part of the design build group, brought out by the main general contractor. So interestingly, even when Kiewit typically is the general contractor, in this project we were invited by the main general contractor to do the large civil work. And as we were talking and discussing the large civil work and assessing the capabilities of our organization, we help also with the design of the work. So as we were able to help with the design of the work, then the team identified the capabilities of Kiewit and pretty much started to provide additional opportunities to Kiewit, which we then ended up helping with the design and then leading a lot of the heavy civil construction of the site development and the large concrete structures. And that's what we're going to be talking today. So an important aspect of this project also is the way the delivery, right? The delivery and integration of the project. This was a construction manager, general contractor, CMGC project. For those that do not know well, this project delivery is pretty much a middle ground between design build and design bid build. In this case, you can see in the figure there on the right that the owner has pretty much, the control of the communication and collaboration and contractual terms with all the different parties, but then they also have to work together and make sure that they integrate and collaborate between each other to provide the best value of the project to the owner. And obviously that there's coordination of all the scheduling work, the design, the pricing, the phasing to improve the design constructability at all times. In many cases, these projects get to a point sometimes in the preliminary phase that the owner may decide to negotiate the contract with the group that is pursuing this early involvement. And in other cases, if that's not successful, then the owner may decide to complete the design and then use a traditional bid build contract if that's what they prefer. So there's a lot of flexibility, there's a lot of integration, collaboration. But obviously, if it is successful in the negotiations, then the construction management group with the designer and all the other subs, becomes pretty much the general contractor too in the project. So just something to understand. But then, why this is of value? What is the value of this CMGC delivery? Well, in general terms, what happened? You reduce uncertainty because now all the team that has been in the early input phase, planning and design, is working together also in the actual design and construction of the project. So then what happened? You get early input from the contractor for planning and design. Then you maximize the design and construction efficiency. And then you have more flexibility to better manage and mitigate the risk. Because now you have all the people integrated under one main roof, and they have to obviously deliver. The need for accelerated project delivery, that's another thing. So when you have these type of contracts, you are able to optimize a lot on the project delivery and look at solutions faster, which then obviously also minimize construction impacts. And as I say, some of the key things are going to be communication, collaboration, and respect. If you're able to achieve those three things, then you get trust. And for you to achieve constructability and productivity in design and construction, trust is a key element of the work. So let's talk about the design and construction. This is now where we get into the more technical side of things. But it's good that everybody understands now where we're coming from and where we're setting the stage. So on the left side, we have the initial original design plan. there were some challenges, especially from the constructability perspective. One of the things were access to the work, concurrent work, challenges that were kind of conflict. Then we need to have the movement of the site material to create the embankment. And then there were some interferences with the tiebacks. And then the column casting was a challenge because it was going to be a casting place. That original design, as you can see on the left, as you see the drawing, was intended to be a slurry wall with tiebacks and then having drill shafts connecting to then a main foundation that was going to hold the casting plate blade columns. So as Kiewit and the design and construction team started working together on revising that plan, especially to get faster, schedule and be able to optimize construction from a constructability perspective, the design changed, as you can see on the right side, and it changed to have then an MSE wall system, and the MSE wall system was going to be pretty much integrated to then the other part of the design of the structure, the foundation structure, which then you can see it has a main mat foundation in the very bottom. Then you have plinth columns with isolation casings. Then on the top, you end up getting another similar mat foundation that we call butterfly plates. That butterfly plates get to an anchor struct system that pretty much goes away from the zone where you're going to have the deflections in seismic events from the MSE wall. And then you have there the stability of the foundation system. And then instead of having a cast in place blade column system, you're going to have a precast blade column system that is going to be built as a segmental precast elements, and then you're going to have external post tension. So then with that, the advantage is further, then you have quicker excavation, you eliminate a lot of the drill shafts, then you can have pre-placement of the plinth columns, improve the design performance of the plinth columns in seismic events, and then the precast columns were going to allow for enhanced construction from a schedule perspective because you have concurrent production as you're building also the other casting place work. So as you can see, very complex system. I'm obviously simplifying here in just figures so you can get an idea of how each of these different points of support look below the main structure that you see that is really nice. But it's a very complex system and a lot of concrete, a lot of mass concrete, high strength concrete, and a lot of different challenges as you're going to see in a few minutes here. So the revised plan you can see there, very, very interesting. The main thing that typically I get asked about this system is the strut and anchor system. What does it do? So what happened, and the reason why you need to bring this into perspective, is the stability of the roof foundation structure. So if you have MSE walls and you have seismic events in this area, then what happened, the MSE wall system doesn't have the stability and then have a lot of deformation. So you need to anchor your structural system away from that area of influence in the seismic event. So then you have a stability in your foundation structure system. The other question is why the isolation casings? Well, the isolation casing to the plinth columns allow for isolating the columns, the structural performance of the reinforced concrete structure from the MSE wall system. So the MSE wall system can have deformations and move in a seismic event independently from the actual roof structure system. So that gives you a little bit perspective for those of you that are trying to figure out why this was done this way. So here you can see a side overview with the open embankment. Obviously, you can imagine the amount of site civil work we needed to do. And one of the reasons why also Kiewit was a good fit. Kiewit being a heavy civil infrastructure contractor, this was also a project that required a lot of movement of material. We use 32 scrapers, and we remove in 100 days over 4.7 million yards of material. At peak, 65 scrapers were part of the material management program to prepare the site. So you can imagine it was beautiful to see first. I'm a concrete guy, but obviously going to site and see the civil work, moving the earth. There were a lot of these big equipment just moving and getting orchestrated and synced into each other without touching each other, and how they were able to move all this material. All this material, the other efficiency that we were able to do is that all the material remain on site. So then you have all this excavation of the bowl, And then all of this material was used for different reasons. So it was used as fill, it was remixed into the backfill of the MSE wall. So we were able to have a very efficient balance of the movement of the material on site. So here you can see, I just want to make sure that you get an idea of the structures. You get to see a little bit of the work of how it looks when you're developing these foundation structures. So a little bit of an overview, because I believe they're going to give you a little bit perspective if you're trying to figure out what exactly all this project means. You can see on the top left, those were the mat foundations there with the plinth columns. That already is on, is under the below grade pretty much. Because all of that is going to be then filled with the MSE embankments, and then you can see the casings, the isolation casings. Those are on the left bottom of the wall of the page, and you can see how they pretty much get to a certain height, and that's going to be the grade level. Then on the right top, you see the little bit of the progress during construction of how this looks from the top once you see the grade level. So once you get to the grade level, you can see obviously the different systems, and you see some of the blade columns coming on top during construction. And then on the bottom right, you see what we talk about, the strut and the blade and the butterfly plates. These look small here, but if you look closer to the image, you can see that there's big equipment next to those structures, and they're pretty heavy. They're all mass concrete, high strength concrete structures. So let's talk one by one. So for the mat foundations, you can see the size. You can see it was going to be obviously heavily reinforced concrete. Those docks that you see there are going to be for the post tension of the system. So all this system is going to be post tension. So you see the docks that are pretty much tying up all the columns, the plinth columns to the mat foundation. You can see there on the bottom right, some photos that show you the view of the mat foundation, the plinth columns as they were under construction. These are 5,000 to 6,500 PSI concrete. The mat foundations are between 8 to 13 feet thick. So you can imagine very, very heavy mass concrete thicknesses there. And then you have the plinth columns with diameters, 5 to 6 feet thick, having between 6,500 to 8,500 PSI concrete strands. Here's another group of photos from the construction, the plinth columns with the isolation casings. As you can see there, the isolation casings provide that ability for the column to move independently from the system of the MSE wall that is going to be in contact surrounding with the isolation casing. Then we talk about the butterfly plates, and I think the most challenging part of this work, when you think about reinforced concrete structures, and we get the blend of construction materials, we get the construction operations, and we get the design professionals, is looking at a system like this one, right? In this one, you have the butterfly plates, which, as you can see on my diagram on the right, it's going to be now coming to above grade. So you get to the above grade elevation over the MSE walls. And then now you see that system is the system that is going to connect to the anchor struts. And you can imagine then the amount of rebar. And this is only, the diagram here is showing only all the different tendons and docks and anchorage that you have in the system to make sure that you transfer loads correctly. And thinking about that, you start thinking about, wow, how can you make this constructible? How design works? How do you make construction good? What type of concrete you use? So we'll talk about that later. This is 8,500 PSI concrete, and the thicknesses of these elements was 8 to 9 feet. So now we're still talking high strength concrete, mass concrete. Then we talk here about the reinforcement details. So you can see there all the docks. This is all the docks. I'm giving you pictures here so you can see the elements amount of reinforcement that we're dealing with. And then you can see here the amount of rebar. This was for a mock-up. So we did a mock-up, a large mock-up, mainly intended to show how we were going to place this concrete. This is a real size mock-up that we just did to assess how we were going to place this concrete, how we're going to be obviously dealing with any of the constructability challenge during construction. And as you can imagine, the first thing I would ask as part of the group is what type of concrete we're going to use, how we're going to vibrate, because you can imagine this large size of work, you cannot do a regular concrete. But we also have mass concrete conditions, so you need to be careful. We went with the self-consolidating mass concrete solution, and that was the best thing we could do, because otherwise we would not have been able to build the structure with internally vibrated concrete. and it would most likely have other technical issues. We did all these structures with self-consolidating concrete, so we could allow the concrete to consolidate all around the bar and docks. And that created some challenges, but we were able to resolve those challenges, as I'm going to explain in a few minutes. Then the other part was the blade columns. So on the blade columns, initially, as you can remember, we had cast in place blade columns. That would have been a challenge from construction perspective. So once we went to precast, you can see the example here. If even as simple as casting your reinforcement, you could be more efficient. You can start building all these different cages of reinforcement and then getting prepared for your segmental precast construction, and you can build it from the inside and from the outside. So you can build faster, you can be more efficient at building it, and you can get obviously better quality of construction with this. So you can see here, we did all these precast construction on site, similar to when we do sometimes construction of bridges. So we established a precast segmental operation on site where we would be doing all these segments for construction of the project. So this just show you here a little bit of an overview of the operations. You can see there the external tendons on the bottom left that are running inside of these precast elements. And this is all tying, you remember the mat foundations, the column planes, and the butterfly plate, and then you have on the top the blade column. So all these systems are post tension, and they're all connected together. As you can imagine, the amount of design and effort that you need to get there for construction too. So then let's talk about the concrete mix. I believe talking about the concrete mix is where some of our attendees here are going to have some interest of understanding. So it was a complex challenge, but I can tell you one of the best things that we can think of was the first thing that we discussed: communication, collaboration, and respect. Once we have all that, we have the trust. And because we have the trust of the group, then we were able to pretty much have the conversations with them and tell them, we want to have low heat concrete. We want to achieve high strength, but instead of just using high strength concrete that is going to be a 20-day strength, we want to make sure that we understand what is the need for design, what is the need for construction, and then why do we need the high strength? In many cases, high strength was needed for the design, but also the design had MOE considerations that we were able to then assess by testing and qualify by testing instead of using the traditional equations. So by doing that, then we did two things. We were able to then assess the actual performance of the concrete from modulus of elasticity, and then obviously provide an adequate strength performance requirement that was going to help us in reducing the heat of the concrete. What does that mean? Well, that means that we're going to have to use then higher fly ash in some cases. We have to use better aggregates. Better aggregates, we were able to get it because in the area that we're building, we have imported aggregates that were able to reduce the water demand. So then the efficiency of the cement is improved. And then we were able to reduce the total cement content. By doing that, we start improving the heat towards the lower heat. And then the higher fly ash is something I challenge the local producers. They look at me first like, you're crazy, we're not going to go that high. I said, yeah, we're going to do 8,500 PSI concrete with 45 and 50% fly ash in a market that doesn't like to go over 25. We're able to qualify all the mixes with between 40 to 50% fly ash, all the mixes high strength between 5,000 PSI to 8,500 PSI. And depending on which application we had, sometimes we had 56 days, sometimes we were allowed to have 90 days. So what does that mean? The collaboration and integration of the design and construction team with the material expert obviously allow for this optimization of the work. And what happened? You have a better product, you still allow for the adequate quality, but then you improve the way you build it. Obviously, as you know here, we're talking about two things that are challenging: lower shrinkage and self-consolidating concrete. So how you have all this balance? Well, with the impact of the improvement of aggregates and then optimization of the material, we were able to reduce the shrinkage by reducing the water content and then enhance it with chemical and mixtures. And then the self-consolidating, we pretty much look at improved aggregate grading. We have already a very good paste and mortar from the mixes that we were using. And then we were just tweaking admixtures and make a beautiful self-consolidated concrete application. Then the self-consolidating concrete, as you can see here, was a big challenge for the butterfly plates. And then we also used it for the blade columns. They were also large and had a lot of rebar. So we had to do some assessments. Important to make sure that you do some large size mock-ups, make sure that you realize exactly how it's going to work, how it's going to travel around precast elements, make sure that there's no horizontal segregation. Many people are concerned about vertical segregation, but when you have material flowing, you also have a potential for horizontal segregation because the aggregates can get trapped in the reinforcement. So that's important. And then in the case of this work, very large structures, you need to assess thermal controls. And with thermal controls, we assess the mixed performance. We allowed for a performance-based thermal control plan at all times. We assess all the properties of the concrete so we can develop the higher temperature differential based on performance testing and analysis. And then we also assess the temperature rise of the mix, which we did several testing with the semi-adiabatic testing, and then we correlated that with the computer for developing the full adiabatic testing, full adiabatic properties. And then by supporting with testing, analysis, and our experience, we were able to have a very efficient thermal control plan that allowed very high temperature differential, and we didn't have any cracking associated thermal. And actually, if I recall correctly, we didn't have much cracking at all, even related to shrinkage, because we were also addressing the low shrinkage mix from a different perspective. So we have low shrinkage, low heat, improved performance-based thermal control plan, and obviously all of that helped with the construction that we didn't have to put any cooling pipes in any of these elements. So you can imagine we're thinking about 8,500 PSI concrete sometimes in elements that were 9 to 13 foot thick. And we didn't need it to put any cooling pipes in those structures. And we did not exceed the temperature limits during construction, which is another win. So very interesting approach for performance. So some of the lessons learned and takeaways, I believe some of the key elements that we're talking today and we need to consider for management in design and construction is communication, collaboration, and respect equal trust. So we need to make sure that you achieve that. If you get the communication, collaboration, respect to get your trust in the project, you're going to be able to be more efficient during the design and construction process. Then some of the interesting detailing wins that we saw was that we knew that we were not going to have the time to follow the typical design process and shop drawing review process. So pretty much we have to say all these parties involved from design and construction needed to come together as one. So we had to pretty much have the whole 3D models and shop drawings started before the engineer had already finalized the design for reinforcement in many cases. That allowed for faster delivery, and then collaboration with all the parties. The construction manager was a key element, the client was a key element. Design engineer and contractor became just one, and they worked together. And actually sometimes the design engineer was talking to the contractor engineers, putting all this work, and we didn't have a lot of layers there obstructing the path of communication. We allow for a continuous flow of communication, which was excellent. And then talking in general terms from productivity and concrete design and construction, importance, promote their involvement, understand design and construction demands, and understanding design and construction demands allow for implementation of all of these performance-based alternatives. You can see that from the design perspective to the construction to the material perspective, all of was driven by performance. How this works, what is the behavior of this, and then how can I make it better? That was extremely important. Then we work as a team using economical choices, not cheap ones, and then we target to exceed expectations. We had a goal for a schedule that was challenging, but we were exceeding it and challenging ourselves to make it work. And the other one is innovate with a purpose. All this innovation you see here from the way design and construction was addressed was with a purpose. And sometimes you get a lot of creativity in the groups, but you need to innovate with a certain purpose. And then obviously be prepared to adjust, because even though we had a very good plan for many things, we had to adjust and change. So with that, hopefully that gives a different perspective there on the topic. Thank you.
Hey, thanks, Oscar. Carrie, I think we are going to need to go ahead and move to our next presentation.
Yep.
Okay. Yeah, thank you very much, Oscar. Very interesting. Our next presenter, Mario Garza, is a senior director for Barton Malow Company and is their infrastructure market leader. He began working with Barton Malow directly out of the University of Michigan, worked his way up through the ranks, superintendent, project manager, and he specializes in complex concrete projects. He is currently serving as vice president and on the board of directors with the American Society of Concrete Contractors. He was also is very active with the Greater Michigan chapter of ACI, having served in the roles of director, board member, and president. He's a voting member of ACI Committee 207 and 306, and is also a member of the Construction Liaison Committee. So let's welcome Mario Garza.
Thank you. Interesting discussion so far. Really looking forward to having the opportunity to talk to you a little bit about some of the things on a little bit more philosophical basis of what we're doing with integrated project delivery and lean and how that ties together. And I think one of the things I'm hoping to bring to the forefront is capturing everything that we've talked about so far. Obviously, with Oscar and what they're doing some pretty dynamic projects and really interesting types of concrete. But I want to look a little bit at the philosophy of the lean and IPD, how we can apply them to contractors of all size, and talk a little bit about the successes that we're seeing on some of our programs, integrating what Mike talked a lot about with technology and how that's driving some of the value in our programs. As an organization, we've really looked at making this case for change, right? I think Mike highlighted a number of the issues that are driving this, but what we're really trying to do is make sure that through changes in contracting methods and through our strategies, we can really highlight our workforce. We can take the talent that's in our engineering markets and integrate them into the process and really get to a point where we're tying that engineer that's doing the design to our workforce and our carpenters and laborers and iron workers that are putting the work in place. How we create that tie, how we create that efficiency, I think is a little bit of what we want to cover there. And it all embraces the technology aspects, the contracting methods, and how we go about all of that in a project. I'll start first with safety. Hey, planning is a big piece of this. I'm going to talk a little bit about the lean and IPD and IPD-ish deliveries. I'm also going to talk about planning and how we incorporate that into our programs in these delivery methods. And it always starts with safety. Taking between the ability to incorporate a model into drone surveys and all of the new technology that's out there, we're able to pre-plan a lot of the things that we're doing, and it ties again to the philosophy with delivery that we're looking at, to be efficient, to really look ahead at what we're going to be dealing with and identify any potential risks that we may be seeing there. So I'm going to minimize this. I think I'm sharing that. Just a little bit about our company. We were founded with trades, and I think that's important to give some context to the conversation. It's not a philosophical thing that we're not doing day in and day out. We currently have, I think we have 1,400 tradesmen this week on the payroll, forecasted to be well north of 1,500 this summer. It's a key piece of what we do as an organization, what we've been doing for close to 100 years. And so as we look at these deliveries, we have that in mind, is how do we incorporate the trades that we self-perform, and how do we bring some of these principles to the table when we're working as a subcontractor. I'm going to go through what lean IPD is. I'm going to go through some of those things. I'm going to go pretty fast because I really don't want this to be an education on what lean and IPD is. I want it to be more about the philosophies of what we do in those environments. So just a high level lean processes, we'll go into these, we'll highlight what they are. But Oscar touched on the trust piece of it, and I think that's one of the most important principles. I've been on projects that have been very, very successful working with engineers that we've worked with for a number of years, and they flow very well because of the trust that's in the process. And really what we're trying to do is take the builders, be it in the mechanical electrical space, being it in the concrete space, being it in the structural steel space, bring them to the table early on in the design process. I think Tom Verdi said it years ago in his ACI speech about, the first 90% of the project 90% of the cost savings opportunities are in the first 10% of the project. And I think that's what we're really trying to do here. How do we bring those to the table even before we break ground during the design process so that we, again, capture the talents of the engineering team with the talents of the construction team, building constructability into that. And so some of the big things that I'm going to touch on as I go through this, some of them I'll go fast. Again, if you're really interested in the IPD piece, Lean Institute does a fantastic job of providing information on that. But I'm going to talk about co-location, big room and co-location, why that works, why that drives constructability, why that's so important. Going back to what Mike was talking about with plywood edges versus nominal lumber, that's when we can accomplish those things. And then contracting methods, right? I think Carrie touched on, whether it be the permitting process and those processes in the industries. That's one of the things we're trying to overcome through our contracting methods with IPD. The other thing that you'll hear me say is whether it's IPD light, I think is what Lean Institute uses, whether it's IPD-ish, using principles of IPD and other deliveries, or whether that's design build collaborative, I think is the term we like to use in-house. All of those are really trying to capture those key pieces of IPD, whether you're able to get there with a full IPD agreement or whether you need to use principles in another form of agreement. We'll talk a little bit more about that as we go forward. So really what we're trying to do is streamline these inefficient processes that traditional construction contracting has brought to the table. If you're a subcontractor that's bidding design, bid, build, we've worked in that space as a concrete subcontractor. The challenges become working against time constraints, battles with the contract structure, the RFI process. And when you compound that across all the trades on a project with the general contractor, an engineer that's contracted to a client, the spaghetti that's created, the inefficiency that's created, difficulties in alignment, all lead to those inefficient processes. And that's what we're trying to do through this, whether it's IPD or design build collaborative, that's what we're trying to improve on, is that efficiency. And so it's going to, like I said, drive safety, quality, shared savings in the program, which benefits obviously the client. And I think that's really where overall construction productivity is going to see those improvements. And a lot of that ties, as we tie back to ACI, how we interpret, how we implement, and how we utilize the standards, codes, and guides that are out there. 8 principles of lean. We'll spend a minute here. Again, you see number 1, respect for people. All of the previous presenters have talked about that trust piece. I can say that I've worked where we have that high level of trust. I've worked on teams that we didn't. We actually on our staff have a clinical psychologist that helps facilitate that. That's how important team is for us, trust is for us. We're going to bring that in. So it's something to really consider if we're going to implement these things. That number 1, respect for people, high level of trust is an extremely important piece to having this be a success. And as we go through the list with continuous improvement, customer value, the value stream, eliminate waste, prefabrication, what you start seeing is we're looking for opportunities to take what talented contractors, talented tradesmen have always said in the field. I think we've all heard that sitting on a job site. Well, if I could have only talked to the engineer, we'd have done this different. That's what we're really trying to facilitate through these processes. As technology is advancing and some of the things that are going on out there, be it from construction robotics to modeling to drone technology, AI as it's coming into the picture, now those opportunities to eliminate waste, to prefabricate things, to create flow on those projects, you can start seeing how it all comes together. And then the last one, pull, right? Pull planning, last planner, whatever we want to call it, and whichever piece of it we want to use. It's been super interesting to hear just last week I heard a debate between a superintendent and a project manager on what the best way to pull was, positives and negatives of last planner system versus doing pull planning directly in the model. And it was fascinating to see that conversation happening at that level, having it be real world experience, not philosophical in a room somewhere, as Mike said, with someone who isn't actively engaged in projects. It was a fascinating conversation to see. So starting to see that these parts and pieces are starting to enter the workforce and be a part of it. And then as we transition to IPD, again, just the fundamental principle of IPD is creating a stake in the game for everybody that is participating, having the bottom line success of the program be tied to all pieces of the program, including our key trades, the prime builder, engineer and architect, and owner. One of the key pieces here, I think sometimes when we talk about these things and we listen to some of these presentations, the feel we get from the subcontract is, if we're not one of the big contractors, we're not going to be at the table, we're not going to be a part of it. And I think what you'll see is selection of those key trades is super important. And I think that's a big piece of it. We'll start with the summary of these. Again, I'm going to spend some time on some of these. I'm going to skip through some of them quickly, just in the essence of time. This one to me is one of the biggest. Hey, the last 12 months have shown us that not being able to co-locate in a big room like we normally do has created a number of challenges that we weren't experiencing in the previous 12 months to that. And so if we ever needed validation that the big room concept worked for us, the last 12 months has forced us into that, as we've been forced to work through Teams and through Zoom. And even though technology has given us that opportunity to continue to interact, it's not the same. And so really what we're trying to accomplish in the big room is having our trade partners, our engineers and architects, our owner, and our construction team, management team, all in the same room. And with that, we're having cost reviews on a regular basis. We're making decisions very early in the process to eliminate wasteful things in the field, like Mike highlighted. We're having those conversations directly with our construction superintendent and our engineer, and having the interaction is what's really, really driving this process. So as we go through all these principles, assuming you can establish that trust, this piece of it, to me, is one of the most important aspects of the whole process that we go through. Target value delivery, again, I'm touch real quick. It's just really making decisions early on and having estimating teams sitting with construction teams, sitting with engineering teams very early in the process allows us to be very, very efficient on cost as it goes to making decisions for what's going to actually end up in the project down the road. So everything from structural steel to mechanical to concrete design, that happens with a very measured set of goals. And again, it's very important. A lot more information. I'm not gonna spend a lot of time there. Same thing with choosing by advantages. You create a framework for decision making that's not just driven by cost, right? And step 2 there, defining the factors is super important. Again, for this to work, high level of trust. It's a pretty detailed process, but I think when these are put in place, it allows you to be pretty quick with decision making early in that process. So last planner system, again, personally, I'm going to say that I think last planner is important, but more important than anything is that we're going to plan. And so I'm going to touch a little bit on work phase planning and some of that we do. I think that all comes from this. It starts with this. This is very important. The key aspect of this is getting all the stakeholders in the room. Okay, this can't be executive or senior leadership planning something out and handing it over to a team. That's what we're overcoming with this. There's a number of ways to do it, from the sticky note method all the way to software packages now that are out there. The bottom line is that you're engaging all stakeholders in that planning process as soon as reasonably possible. And then that transitions into the field, and that transitions into our execution. Again, focused on driving that efficiency early in the process. Success methodology, I think, again, this is out there, very important. I'm not going to spend a ton of time here today just because I got to get through a few other things. And then the visual management. This to me becomes super important. I know Chris talks a lot about the email vortex, right, that's created. But the reality that we're finding is that if we get creative with the way we do our visuals and utilize our technology, everything from in-plant job boxes to in-plant stations in the field that our tradesmen can utilize and access these plans on a frequent basis. Again, giving them an idea of what we're trying to do, having them be a part of that planning process so that everybody on the team knows the execution strategy when we go out there. And it's no different than a Super Bowl winning football team going out there and understanding the game plan from day one. If everybody on the team understands the game plan, tends to lead to successful outcomes, and it's no different there. Getting everybody from the superintendent to the foreman level to the carpenter level, understanding the game plan day in and day out. And then the IPD practices. And again, the real principle for this is changing the methodology that we look at our contracting practices. And so this early selection piece becomes very important. Again, this obviously starts with a motivated owner. That's why we tend to say, hey, the IPD thing is great, but if we can at least get to a collaborative design build process, then that'll allow us to implement a number of these principles from the IPD process. Form of agreement. Now, this is the roadblock. This is where everybody hits that challenge with IPD. And that's why every time we hear the term IPD, we need to look at, hey, what can we learn from IPD? What practices from IPD can we implement into our design build practices so that we can then have those successes, even if the form of agreement is going to be an issue down the road. Hey, we do a lot of this. We've recently executed an extremely large automotive project on an true IPD contract. In the industrial space, it's one of the only ones we've ever executed, if not the only one we've ever executed. It is a challenge, but again, that's why we focus on those IPD-ish principles and that design build collaborative mentality. An important piece of it, again, joint goals that we need to establish. This leads to the overall success of the program. It doesn't tie quite to the execution piece that we want to talk about today. The risk reward, I think this one from a subcontractor perspective, for us as a contractor that self-performs, we understand this piece and we want to be a part of this piece because we want to drive that cost down, drive efficiency to help us with gain. I think from a subcontractor standpoint, if you can find a constructor that there is a high level of trust with, this is where you can be a part of that team, and we can have a lot of success in defining this up front, understanding that every stakeholder in the room is at risk, and then being able to drive decisions based on that risk profile. And again, it can't keep saying it enough. It all starts with trust and being able to have those conversations with the other stakeholders that are going to drive good decisions, are going to be honest and difficult, and really lead to overcoming those challenges early on. And joint control, again, there's tools there to get that. I'm not going to spend a lot of time on it. Dispute mitigation. This one goes back to, again, those contracting methods and the confusion that's caused and the issues that are caused through the way we contract our subcontractors. How many of those projects, especially the difficult projects with very accelerated schedules, lead to issues at the end of the program from a legal standpoint? That's one of the big goals here, is how do we get that settled up front, get it settled in the boardroom before we ever before we ever mobilize on a project, so that we aren't dealing with those issues down the road and becoming inefficient when those problems start coming up during the execution of the program. But again, I know that's quick. Again, IPD, if you really, really want to dive into it, Lean Institute does a great job of highlighting that. There's a lot of information out there. Last couple minutes here, I want to touch on installation work planning, because I think that as we develop these work packages, it's something that we started as a subcontractor. We started implementing into our design build. It's evolved from 20 years ago when I was working as a layout engineer, doing it in a field book and marking up drawings, to then, hey, we're going to have some lift plans, to getting to a full-blown installation work package and executing on some work phase planning. I think Mike showed a slide that if, those opportunities in the early phases that are going to be driven by pre-planning and advanced planning are going to lead to those successes in the field, be it on cost, be it on productivity, be it on quality of execution. The work packaging process that we go through is really driving that piece. And on the right, you see the outcome. This is one of our installation work packages that's live. We use BIM 360. I know there's a number of platforms. Everything that the team needs to execute, from emergency and safety contacts to quality to reference drawings, is all linked and all available to our team right on the one plan. This is the advanced work packaging philosophy. Again, this is out there. Take some time if you want to learn it. Really, I want to focus, especially in the ACI world, down to that work package planning in the field. Advanced work packaging, getting pretty advanced. To be honest, not something we do very often, if at all. And this is really the key, right? Understanding the appropriate level to implement into our programs. And so the real focus for us is on that, from a self-perform standpoint, is on that standard work packaging, those early systems, making sure that that work phase planning is happening day in and day out. And more importantly, that these installation work packages that we're creating and this output that's being generated is being done with our project engineers, superintendents, and foremen into it. So it starts with our work package development, with our WBS, and eventually gets down to our installation work packages. And that's where I'll touch on right here. This is the key. Superintendents, foremen, PEs, not project managers, not project directors, not project executives. The individuals that are putting the work into place, that are executing the game plan for the day, need to be the individuals that are helping to develop that work package and that will develop that plan. Understanding the scorecard, understanding how we're going to keep score, and then again, understanding the goals through the execution and what that game plan is. Typically, we pair up a foreman with a project engineer, and that team is what develops these packages. And again, you see the output. These are concrete specific, but we do it with all our trades. We do it on the structural steel world and mechanical equipment installation world. These have been one of the best tools that we've used in the last few years to make sure that our teams are on the same page. And again, a lot of time can be spent on getting into the specifics of what we put on our installation work packages. But the real key to both the contracting method and the installation work package method is understanding what that end product's going to be, what that end intended use is, what that turnover package is going to look like for the client, depending on what market you're in, working that plan backwards to day one, and then having that opportunity to work with the entire team, owner, architect, engineer, contractor, trade partners, to execute and develop a plan that's going to ultimately help us with that turnover to the client. And that's what I've got. Thanks for the time.
Thanks, Mario. I'm going to go ahead and share the last PDH code. We're running a little bit behind schedule. I'm not sure. I know some people are trying to get out to go to some other sessions that start at 1, so I wanted to make sure you could get that last PDH code. Okay. So it's R92A. Was there anything you wanted to say, Carrie? We will probably do questions.
Yeah,
keep sending in questions. We'll handle those during the final part of this session where we get everybody back together.
Okay, good enough. All right. Well, thank you very much, Mario. Very interesting, very informative. Our final presenter, Mike Tholen. Mike is ACI's Managing Director for Engineering and Professional Development. Mike is a graduate of the University of Kansas. He received his BS in Architectural Engineering with distinction in 1992, his MS in 1995, and a PhD in Civil Engineering in 1996. He joined the ACI in 2005, and prior to that, he spent 8 years as a structural engineer with Burns and McDonnell in Kansas City, Missouri. Mike and his wife, Lisa, have 3 boys, and he lives in Fowlerville, Michigan, not too far from ACI's headquarters. Take it away, Mike.
Hey, thanks, Gary. Good afternoon, everyone. I hope your convention is going well. I'm going to talk to you today switch gears a little bit here and talk about one of our newest products at ACI. It's ACI 318 Plus, but also talk about how we can communicate with the design community using this product. Carrie's been chairing a product board, ACI board task group on productivity in the concrete industry, and some of the ideas that that group is looking at for how ACI can help to increase productivity involve getting information out to the designers and making sure that they have proper information on topics such as constructability. So today's talk, I'm going to talk about how what sort of needs created the need for this product. We'll go into some of the general overview of the features. I'll give you a little bit of product demonstration and talk about constructability and that, and then we'll wrap up with just a brief discussion about how we can use this product to communicate specifically on constructability. So the real reason for this topic stems from a couple different thoughts. The first is that ACI has just a tremendous amount of knowledge. We have that ACI collection, which takes up about 18 inches on your bookshelf if you get the hard copy version. Several of those documents get revised every year. That's all of our committee documents. I believe we're on around our 350th symposium publication that contains, each one of those contains several papers. We put out periodicals through our journals. Our Concrete International magazine comes out every month, and one of the other journals comes out every month. And then we're also starting to get a lot of information and presentations like the session you're watching now and other sessions that have been going on at convention that are non-print types of concrete knowledge. So through all the work that our great volunteers put together, ACI just has this tremendous amount of knowledge. And the result is if you want to know something about concrete, it's very likely that ACI is going to have an answer for you somewhere. One of the drawbacks is that it's a lot of information. And if you can imagine when you were first exposed to ACI and trying to find a specific answer to a specific question, even if all you knew were the committee documents, there was a lot of information to look through. Sort of the other side that developed a need for this is we have a document, ACI 318. That's our code document. It's our most well-known document. It sells more copies, brings in more revenue than any other document. It's so far above the rest of the documents that you have to take it off of any graphs of sales or anything, or you just can't see what the other documents are doing. It's what ACI is known for, if people know us for one thing in the industry. But it's a very terse mandatory language document. 318 is not about teaching you how to design. It's about giving you the rules and letting you figure out how to implement those rules in your design. Okay, so it's not going to, it brings up a tremendous array of topics that you need to know about, but it doesn't give you the information that you need to really intelligently implement those code provisions. There's a little bit of commentary. More often than not, that's more background information for how the provision came about. So it's not an educational tool. And unfortunately, so many people know about ACI 318, but at the very least, they don't realize all of the other different types of information that they can get from ACI. Okay. They may know of a couple other committee documents. They may know of the ones that are typically referenced in 318, but in general, we find that a lot of people are just not aware of all those other documents. So the idea for this ACI Plus platform was, at least for the first product that we put out on that platform, we're going to take our most popular product, ACI 318, and create connections from topics mentioned in 318 to all of our other products, all of our other sources of knowledge, whether it be a committee document that's in the collection, a professional development course, perhaps a CI article that just got published last month. Okay, so that's the main idea of the platform. Getting into the features, one of the really key features of this is we've made it web-based, and that allows us to, it's available 24/7. It allows us to link to almost any sort of digital information that we have, which is most of the information that we have now can be digitized. Not the only thing we can't do anymore is nice social events like we're used to at conventions like this to get to know each other. Those are still somewhat of a struggle for us. But having it be web-based also has another key feature, and that's that we can modify the 318 Plus. It's not, we launched it on March 1st. It was not done on March 1st. It's not done today. It probably won't be done at least until 318.25 comes out and we get it up on that platform, because ACI continues to produce more information and journal papers and new documents and CI articles and new courses that come out, recordings from this session or this convention. We can work all of that information into the 318 Plus product as it comes out. And that allows us to create those connections to the latest information, to really good products as they come out live. I got to admit it, when we first started this project, I thought, yeah, it'd be nice if we could have some notes that we could put into the product. But I wasn't expecting it to be a major enhancement to the product. It's turned out to be possibly one of the key features of this, and I'm going to get into that a little bit later. Of course, anything electronic, you really want a good search function. We've added some the way we present the results, I believe, will help a lot. We do have some 3D graphics. I probably won't have time to show you those today, and there are several other features I just don't have time to go into. So to access the product, you would go to the ACI website, and under publications, there's a link to 318 Plus. Anybody who's purchased a copy of ACI 318.19 from ACI, we have a record of that. If you go into the store and try to buy the subscription, it will give you a free first year for the subscription. And this is not the HBO 3 months free, where if you put in your credit card, we'll be sure and redo this right away. This is no strings attached. We really want people to get in and see this product and understand what it can do for you. It's just so much different than anything we've done before that it really wasn't going to be fair to ask people to buy something that they'd never seen anything like it before. So when I click on 318 Plus and I have my subscription, I get this splash screen that you see here. We'll blow that up a little bit. You'll see that there's 4 different documents. The first is ACI 318. The second is our detailing manual, which I'll go into a little bit, some of the links here in just a minute. The third is a reinforced concrete design handbook, and we actually delayed the launch of 318 Plus by a few months so that we could get those 2 documents done and integrated into this product. So when you buy access to ACI 318 Plus, you're actually getting access also into the detailing manual and the reinforced concrete design handbook. The ACI 318 Plus support documentation is just additional information on the features. If I click on ACI 318.19, it takes me to the beginning of that document, and it looks kind of like you would expect. In the center, there's a representation of the code, all your navigation and the search functions are on the left. And then there's a lot of white space over here right now, but that's where the notes appear. So I'll talk about those later. I happen to have those turned off on this screen. Speaking of navigation, it's very intuitive. You can expand the folders in the table of contents on the left. If you click one of those sections like Chapter 9, if you're designing a beam, it will take you straight to that section. The search functions, you type in a search word. There are some options that you can pick, such as whether you're looking for all words or you want to treat it as a phrase. And then the nice thing that I think about our search function is that it doesn't just return a list of results. It gives you the first 10 to 12 words from the provision that term is found in. So I find that makes it a lot easier for me to get quickly to what I'm really looking for. Some words will come up all over the place in 318, but it's usually a specific location that I'm trying to locate that I want to get to. And that you'll see is kind of a theme as I talk about this product. We wanted to be able to get not only people to the right resource, but the right section of the right resource so they can get it done quickly. And then of course, then of course you can also scroll. One of the nice things about using the table of contents and clicking around or an internal link is that because it's a browser, I can go back and forth with my back and forward arrows. Makes it much easier if I go down the wrong direction to come back and back out of it and get back to where I was. So the one thing you may have noticed that's different, that's not in ACI 318, are these symbols that occur under most of the provisions. So that's what we're going to talk about next. So each one of the different resources, different categories of resource has a different symbol that's attached to it. When there's a CI article that's attached as a resource that you might want to look into for a topic mentioned in a specific provision, the CI icon is what we call them. That icon will appear underneath the provision number. And that's because we wanted to give people a visual clue what type of resources were linked in there. Because if you want to take a deep dive into a topic, you know, maybe a CI article is not what you want to go for. You want to be looking around for something more like some sort of publication, like a practice or a standard. You may really like to watch videos of people presenting technical topics to you, and in that case, the video icon would catch your eye. So one of the first ones I'm going to talk about, go into a couple of these in detail, is the detailing manual. Here you see in chapter 9, we're in section 9.7, the reinforcement detailing section, and there, that icon that I showed you was a detailing manual icon, appears underneath there. If I click on that icon, I get a couple different links, a short note. We usually try to provide a short note for the resource that we're going to take you to. It's not a detail, it's not a summary of what you're going to find. It's really just what we thought was enough information to let you decide if that resource was something that you wanted to investigate. When possible, we'll actually give you section numbers or page numbers of the product that we're taking you to if we're taking you to a specific section. That allows you to use your paper copies if you have them. If you don't have access to a particular product that we're taking you to, and get you, again, to that information we wanted you to see as quickly as possible. So when I click on that, that takes me to the section 2, chapter 2. There's some bean details. So this was a link from the bean design chapter. I see this detail. Each one of these details has a list. I believe there's over 100 details in the detailing manual. They all have a list of considerations. Some of these are constructability considerations. This was reviewed by our constructability, a couple of committee members from our constructability committee. So hopefully we have the constructability kinks worked out of these. And then there are also links to CI articles that are in the back of our new detailing manual. And I should mention that all of those details are available for download as CAD drawings in our ACI store. Getting back to the detailing corner articles, each of those details, there's a note that tells you which CI articles, detailing corner articles, are appropriate for that that provision or that detail. I'm sorry. Another example would be how our standards and our practices work. So our standards are our codes and specs, and our practices are our committee reports and guides. Here I'm in chapter 13. You'll notice that there's a link here. So most of the time, the link that's here will also show up in its appropriate icon under the list here. Occasionally, we run out of words to link, so some of the icon links don't make it into the text. But when you hover over that, it will pull up the note, the same note that would appear if you clicked on the icon. So I can hover over that. Lets me know that there's some more information about drill piers. Here we're taking you to section 4.75 and letting you know it's on page 17. So one of the differences between this and the detailing manual is that we haven't got all of our committee reports and other documents into the PLUS platform. So when I click on that link, I'm just going to pull up at the beginning of the document. I need to look back at that note and remember that I need to go to a specific section or a specific page. If I'm a member, A member benefit now is that everybody gets electronic access to the ACI guides and reports. So in this case, since I was a member looking at this, that document pulled up right away. If I was a non-member, I didn't have electronic access as part of my member or part of my profile, I would be taking to our abstracts portal, summary of the document and some information about what subscriptions it's available in, and looking at the store. As I said, education for the board committee on productivity is going to be a big emphasis. So there are ACI University courses that can be linked in. Again, those were free member benefit. And so getting onto that idea of what kind of access do you get in here? Everything you see on the screen now, all of those different types of resources for the most part are free, or you can go directly into them once you purchase the ACI 318 Plus subscription or gotten your free one since you bought a copy of 318. The ones you see here, the CI articles, ACI University, and all of our practices, which are our guides or reports, those are the ones that come along with membership now. So if you're a member and you have a subscription, you could get into all the ones that are on the screen. And then these last two typically require some sort of an additional subscription or an additional purchase to be able to get right into those. Talking about our user notes, the reason those are important is that and became such a big deal to us, where they're actually allow the ability for the user to customize 318 Plus. Each user can do up to 10 sets of notes. And what really, I think, changed the game for this is when we were able to work out a system where you can share those notes with other people and other people can share your notes with them. So this allows, say, an entire office, maybe Carrie's office wants to make some notes about constructability. Well, they can have a set of notes about parking garage constructability and the issues that he brought up with some of those projects there. And those notes, as I'll show you here in a minute, can actually be right next to the provisions, the most pertinent provisions in the code. Okay, so and then he can share that with his entire company. Okay, so this allows engineering companies, professors. We could do a set of notes that talked about constructability from ACI and put that out and have people add that into their 318 Plus. Here I've turned the notes on. You see them on the right. When I click, pardon me. Oops, I'm sorry. So off here on the left, a couple of the buttons control the notes. The first one allows you to select which of those note sets you want to show. The next one brings up a notes management interface where I can add new sets of notes and share it with other people. So here's an example of a note that I'd like to, for example, I might want to use. I'm in the anchorage chapter. I'm calculating the bond strength of an adhesive anchor. So I want to go in here and I put a note in here that here's a catalog from an anchor manufacturer that I like. You'll notice the catalog here is in blue. That means that I've hyperlinked it. So when I click on that link, I'll go right out to a PDF of the manufacturer's catalog. And I made a little note to myself that the value I need, tau critical, in the equation that goes along with this provision is given on page 102. So I can get right into that. And that's a way that I can customize this product for myself. Perhaps the anchor manufacturer may want to produce a set of notes to go along with chapter 17 and provide links directly into their data and then be able to share that with their customers. So I save that note. It appears, as I said, right next to the provision. Wrapping up here. So hopefully you've seen how this product can handle really a vast array, almost all of the products that we currently have, and we can develop, we program this in-house, so if there's something that we don't currently support, it's possible that we will be able to support it later on. The product itself is very designer focused. It's a version of 318, and the links are really focused towards the designer, just like constructability as a topic would be, so the audience is fit. We have a lot of current resources that deal with constructability that we've already linked in there, and as new ones get developed, we can easily add those to the resources that are in the product because it's web-based, and as soon as we transition it it can be uploaded to our servers and be ready to go. So that's the end of the presentation that I have. Let me check, stop sharing my screen here, and I'll look and see if we have some questions. I know that we had some from before. Sorry. Carrie, there was one that popped up from your previous session that says, what was the long span beam solution brought to the table to solve the drainage issue?
Oh, that's a very good question. That particular issue was pretty easy to resolve. We moved the drains. If you recall the image I showed, the drains were located at the intersection of the beams and girders. The beams were 60 feet long. And so as you migrated down the beam, there was anticipated originally to be a high point at the midspan of the beam. That's what I showed on the image. And all we did is increase the drainage basin length so that the drains were still located at the intersections of beams and girders, but the beams always travel in a straight line. So one beam slopes up 2% to a column and the next beam slopes down 2% to the next column, but you never require kinking a beam or changing slab thickness. There were other constructability challenges in that project. I think Mike Schneider may have alluded to a few of those, but the drainage issue was pretty easy to resolve. I think we should probably all go on camera here at this point, huh?
Yeah, if the rest of the participants or the presenters want to go ahead and turn their cameras on and get their microphones turned on. See, another one that came in for Carrie. How much do mock-ups help in finding constructability issues similar to the ones you've mentioned?
Oh boy, they can help an awful lot. They can help an awful lot, especially if you have one-off details or details that the people involved in the project don't have any direct experience with, whether it be beam girder, beam column intersections that appear to be overly congested, things of that nature. The first project I showed, which was the Las Vegas Tower, the one that eventually got demolished, would have really benefited from some mock-ups, because the mock-ups would have shown that many of the details that were created were literally impossible to build. You could not build what was drawn. But that was a very, very rapid schedule, and apparently there was no time to do any of that, and so it got into trouble because of it.
Do any of our other panelists have any comments on mock-ups, whether they're helpful or not? Yeah, Mike?
Yeah, years ago before BIM, we had a large project on a convention center, and on that there was the structural stuff. You know, it was post tension, big beams, lots of re-steel, but then you also had the electric and the plumbing lines that went in to supply the boxes that you'll find in convention center floors. And we were already on a prior package and talked to the construction manager about the value of a mock-up. And we built a full bay mock-up. It was an elevated deck. And when we built the mock-up, what we found out that mathematically, the PT, the way it was designed, there mathematically wasn't enough room in the bulkhead to put the heads for the anchors. And we just called them out there and said, what do we do here? And that was before we started putting in the electric conduit and the water lines. So, but that mock-up was part of the pre-bid meeting, because again, our concern was sometimes you see it on the drawings, but you're not, they're on different drawings. If you're looking at the structural, you don't see the plumbing and the electrical.
Yeah.
And this was all there, and everybody went out there and looked at it. And they used it for the concrete package, but they also used it for the mechanical trades when they looked at it. So they were all aware of what the congestion was and what the conditions were. Worked out very well.
Great. Mario or Oscar, do you have anything to add on that?
I would say yes. Mock-ups are a key element of design and construction. I would say for concrete materials and constructability, field operations is a key element of the work. Now, the key about also doing mock-ups is representative level of effort, right? So you need to make sure that you're not just taking these isolated from the actual operations and making this pristine, beautiful thing that it's not going to be able to be repeated. You need to make sure that you are approaching it in a way to first learn what are the objectives of the mock-up. If you're trying to just check clashes or check, if the concrete is going to flow or if the pressure, the forms are going to work out, that's something different. But also making sure that you have all the parties involved. You want your architect, your designer, the different subs, because then expectations can be established in the field based on the observations that you're making. So.
Mauro, anything to add?
No, I mean, again, I think a lot of it can be done, through that model coordination if you take it to the right level of design, but, or development, I should say, but, yeah, they pretty much answered it.
So
Okay.
I would add one other thing on the mock-up, the physical mock-up, not a model, is finishes. I'm sure all the contractors on the call have had issues with finishes. And again, to echo what Oscar had, make sure it's something that's repeatable, scalable. But again, the other thing I have seen is halfway through the job, all of a sudden the mock-up is gone. Somebody tears it. So put the mock-up somewhere where it can stay for the project. And when you get to the end and the owners or the designer is talking about the finishes, it's very important that mock-up is there. And it's all about trying to control expectations. Not control, manage expectations.
Yeah, I thought this was an interesting question. Do you think that Chapter 17 special inspections and tests in IBC is delaying concrete projects and making them more costly?
Read that one again, Mike. What's the question?
Basically, do you think there's any role that the special inspections and tests required by the IBC are those delaying concrete projects and making them more costly?
I personally don't think so. I think there is certainly room for improvement in the world of special inspection, because that can be an issue on projects where you have somebody assigned to the project who doesn't have the experience to really help or identify problems. But I don't think they, with rare exceptions, I don't think they stand in the way of progress or they slow things down. I don't know what the other panelists think.
Yeah, I'll jump in and say something about testing and inspection. I think, blaming testing and inspection for issues is a little bit unfortunate, but the key is about understanding the goals and expectations from the get-go, right? And then having the right experience and collaboration as people implement the inspection and testing findings. Because if you have somebody that doesn't understand it, don't know how to use that information, and then that doesn't have a true goal and expectation from what they're looking for and why they're using those special inspections and tests, then you have a problem. Because all of a sudden, people think that the sky is falling, but it's actually just giving you an indication of first where you can improve, where you may be able to figure out better solutions, and then if there's a true problem or not, right? And as everybody in the panel here know, as you get experience and you get exposed to more work, you realize that there's a lot you don't know, that you're learning, that you know that it's a problem and may not be a problem.
Yeah, I'd say the same thing as that's where the installation work packages became so important to us. It really came out of our industrial process teams. And as we were working on those turnover packages and commissioning, and, to Oscar's point, it applies to any kind of testing and inspection, understanding those expectations very, very early in the process, so that before we ever started construction, we were building those plans for turnover packages. That way we could check those boxes as we went along. It was expected, it was planned for, and the expectation didn't get us off track as we were getting to those points in the process.
Correct.
Okay, Our next question, if I'm understanding it correctly, really has a couple different parts. Do any of you have any comments on innovative methods of construction that might increase productivity, the modular construction, 3D printing, any robotics or anything like that? And then sort of, it looks like on the contractual and the permitting side, are there any innovative methods that you see coming down the road that will increase productivity?
Boy, that's a short question with a long answer.
Yeah.
We can talk about that one today.
I mean, we have an entire department dedicated to just answering that question, right? Whether it be the interaction with companies like Construction Robotics that are making things that support the masonry side of it more than they support anything else. That automated, what do they call it? That automated mason that they have, and getting into the virtual world and how AI plays into everything from a planning perspective, and getting into drone flights. But as it drives actual productivity, I think it's more driving efficiency than productivity. I think the productivity side of it comes in when you can take talented tradesmen and give them some tools that help them communicate better with the rest of the team. I think that's always one of the challenges. I think that's where the technology is helping the tradesmen, but overall program efficiency is coming from some of those other aspects.
I think one of the big challenges with innovation in general, we all welcome that. That's what moves any industry forward. In the world of construction, a lot of innovation comes from people who have commercial interests in mind, which is a good thing. So suppliers, fabricators, whatever. And they're developed to benefit the innovator, not the project. So innovation, one of the speakers said, innovation needs a purpose. And the purpose ought to be to benefit the project, not the person who's providing the innovation.
You're correct, Kerry, and that was me. I believe that the first question is do we have any comments of where innovative methods increase productivity? I believe it can increase, it can affect. You just need to figure out where to put it right. For example, you're not going to be 3D printing in a location that you don't know, that you don't have the access for all the different equipment, or where you believe that you don't have even the ability to execute the work that is designed for, and actually the design was performed for 3D printing. That's just an example. But there's certainly lots of opportunity to use technology in different applications to increase productivity, and that has been shown different ways. The key about that question is how the user, the practitioner, is actually understanding the value of the innovation, and how are they matching and fitting the innovation in their design and construction. Because I can tell you in infrastructure, we get a lot into this with some public work. Public agencies sometimes obviously either are afraid of innovation, or they just want to push innovation without knowing how to use it. And that's where the challenge becomes, because then first, they're not adapting to the new things that are coming through the markets. And the second thing is, like, all of a sudden they want to use something because apparently it's innovative, but it doesn't fit. And if it doesn't fit the application, why would you use it? There's no value for it.
Yeah.
So that's a great point. I mean, you look at something even specific to concrete, even as simple as steel fiber technology, and how many times we work with ready-mix suppliers that say, hey, if you guys are familiar with this, can you help us with the batching and dosing, because we're just not that familiar with that part of it. So it just, it has its application. We're prepared, in that specific instance to help it. But to Oscar's point, I think I said it earlier, that discussion that I was listening to specific to pole planning, right? Because every client, everybody sees this tool and says we have to be doing it. To hear that in-depth debate as to how to best plan using all these different pieces of technology that are out there, it was fascinating. I mean, it was kind of fun to listen to see that, okay, they're actually buying into this because they're saying, no, that doesn't work, and here's why. Not just, I don't want to do it. Instead, they're saying, I want to do this because I can accomplish that goal with it. And so the more we get some of this stuff in their hands, I think the more, to Oscar's point, they start validating that use and when it's appropriate.
Okay, and the last question we have up here, it's pretty specific, but going all the way back to the beginning when Carrie, when you showed the productivity between different industries, what was the metric for productivity in construction relative to the other industries? Do you know that? I know there were maybe a few caveats you also wanted to share about those charts.
Yeah, first of all, you can find the McKinsey report on the internet. If you Google McKinsey 2017 construction or something along those lines, it'll come up. There's a short version, a long version, lots of data. So I would encourage you to read it. It's very enlightening. But the metric they used was the value added per unit of hour worked. So for each hour of labor expended, how much value is created? And the metric was dollars. So I believe in construction, currently we're adding an average of $25 of value per unit of hour worked, and aggregated industry is adding 37. Don't quote me on that. You'll find that in the report, but I'm pretty sure those are the numbers. But that was the metric, the value created per unit of time, value created per hour worked. And that's a standard economic measure. How much value does each person create per unit of time?
Okay, well, that's all the questions that we've had come in, unless some people are typing some more. Did anybody have any closing comments they wanted to make?
You know, one quick comment, I did check during one of the other speakers programs here with a company advisor on the project we did in Las Vegas, the expert work we did. And that was, they said no problem to release it because it's a closed case now. So the building was the Harmon Tower, Harmon, Harmon Tower, Las Vegas, which is no longer with us. It's gone.
Yeah, I would say, Mike, from a general perspective, our audience are, ACI members, and some of them are not, but most of them are ACI members. I believe a lot of the things that we get from this session is there's a lot of opportunity to improve on constructability and productivity within even the way we develop ACI documents and the way we write things in ACI documents. It's never going to be perfect, but I believe if we think about constructability when we're putting requirements and how that requirement can actually be productive to the field operations, how can that allow the designer to have opportunities to better improve using performance and understanding the behavior of the structures and all of that, instead of putting more restrictions in our own documents. I believe that's important that we as ACI members consider, because at the end we need to maintain a safe environment, but also a reasonable opportunity for the practitioners to use information and be able to use standard practices to get to design and build the work.
Mm-hmm. Okay, anyone else?
I'd like to thank everybody for attending, and hopefully you found this valuable and enjoy
Yes.
the rest of the convention.
Thanks, everyone.
Thank you.
Thank you.
Everybody have a great day.
You too.
Nice job, Mike.
Thanks, Mike.
I tell you, that tool has got lots of potential.
Oh yeah, we're finding different ideas every couple of days. There'll be a lot to keep up with, and when we get all the documents in there, that'll be quite the tool. I think that'll really open things up. We're even thinking about using it as part of our document development process. So basically, like a committee, say like 318, could go into sort of a back door of that project, put in their change proposals, and it would show what does the new code look like? Does it make sense in context with all the other stuff? And then just when it passes, they check the box and it puts it in there, and the next change proposal comes up and they can see it in context with the next one. And so it could really be a game changer, I think.
Okay, very good. We'll talk to you later.
See you later.